All right, so we are actually ready to move on with solving systems of equations. And so we're going to have to do a little bit more work. So last week we were looking for things that eliminated or made zero. Today there will not be any numbers that eliminate, so we're going to have to do a little bit of work to do that. So if you guys look at the x terms, we have a 3 and a 6. And on the y terms, we have a 6 and a 3. It actually doesn't matter which one we get to eliminate. It's just as long as one of them is positive and one is negative, and then we can solve for them later. So I'm going to pick my x's just because the 3 is already positive and the 6 is negative. So if we look at these, what number do 3 and 6, what can they both go into? And they both go into 6. So I already have my 6 here, so it's actually not going to change at all. Now, the top equation, if I want to make this term a 6x, I would need to multiply this equation by 2. So we're going to multiply the entire top line by 2 to get 6x minus 12y equals 6. Now, our 6x's, we have a positive and a negative 6, so we can eliminate those and then combine what's left. So a negative 12 and a negative 3 gives me a negative 15y, 6 and a positive 24, so we're going to add those and we get 30, and we divide to get negative 2. Now, just like last week, we got to plug that number back in. It doesn't matter if you pick the top or the bottom equation. I'm going to pick the top equation just because it is smaller numbers to work with. So I went back to the original, 3x minus 6y equals 3, and I plugged in my negative 2. So now to solve that, I got 3x plus 12 equals 3, and then I can subtract my 12 from both sides. 3 minus 12 gives me a negative 9, and I divide and get negative 3. And then as always, we write our answer as an ordered pair. X goes first, and then our y coordinate. All right, now on the second example, it's kind of like that. We got to get one of these to cancel. We have a 5x and a 2x. Both of those, we could make those 10, or we could look at 12y and 2y. They could both be 12. And so this would be a little bit easier because 2 goes into 12. So we're basically just saying we're going to keep this one a positive 12y, but we want this to be a negative 12, so we're going to multiply by 6. So we get negative 12x minus 12y equals negative 48. So the y's eliminate this time. And then our remainder, 5 minus 12 is negative 7x. 27 minus 48, if you need a calculator, you can always use those. So you got 27 minus 48, and that gives us a negative 21. So then we can divide by negative 7, and 2 negatives are going to give me a positive 3 for my x. Then at this point, you can pick top or bottom. And again, it does not matter. I'm going to just go with the top, but that's totally a personal preference. And so then 5 times 3 for x gives me a 15. And then I subtract 15. And I get 12y equals 12, and then I get y is 1 when I divide. So our solution here is 3, 1. And just like always, you can plug those originals right into Desmos and check your work, but you just have to show your work to back it up to get the credit. All right, so we are going to do a couple more examples together, and then I'm going to give you a couple to try on your own. So the first example we're looking at is number 3. All right, these two numbers here, we want them to be opposites of each other. So the only number that 7 and 8 both, we could either choose to make these 56x, which might not be the easiest to do. 3 and 5 both go into 15. So we have to make the choice. Are we going to make the x terms positive 56 and negative 56, or are we going to make the y's 15y? I would say doing this is going to be easier. So in order to get this to be 15, I got to take it times 5. And then the bottom, I'm going to take it times 3. and I get 40x minus 15y equals negative 30. And on bottom I get 21x minus 15y equals 29 times 3 gives me 87, but it's a negative 87. Now right now, both 15s are negative. So we do need to change the signs in one of them. I'm going to pick the bottom one. And so then we have 40 minus 21, which is 19x. The y's eliminate. Negative 30 plus 87 gives me 57. And divide that by 19. And I get an answer of 3 for x. So then we just got to go back in and plug that in. Again, I'm choosing the top equation. So we get 24 minus 3y equals negative 6. Subtract 24 from both sides. And two negatives are going to make that a negative 30. And then I divide negative 30 by negative 3 to get a positive 10. And we have our results. Sorry, my angle got a little crazy on that one. All right, and then on number 4, we are doing that exact same thing. 2 doesn't go into 5, 4 doesn't go into 5, so we just have to look. You see how these x's are opposite signs? That means they'll be easier to cancel out. 5 and 2, we're going to try to make both of these 10x. So we got to multiply this by 2, and we got to multiply this by 5. So then that gives us negative 10x minus 8y equals 8. And the bottom, positive 10x minus 25y equals, and negative 28 times 5 gives me a negative 140. My x's eliminate, and I'm left with negative 33y equals negative 132. Now I'm going to divide that by negative 33, and I get an answer of y is positive 4. Now I can pick whichever one. I'm still going with the top, but that's your choice. All right, so we get negative 5x minus 16 equals 4. And we add that over and get 20, which divides to negative 4. My x coordinate and then my y coordinate, and here I got my solution. All right, so we are almost finished. So we've got a couple more to do, and I'll move that so you can see a little better. All right, so here we do not have opposite signs, but guess what? We can just change this right off the bat. So they do. All right, if you don't know a number that 18 and 14 both go into, just multiply the top by 14 and the bottom by 18. Just multiply them by the opposites, and then they will end up being the same coefficient. So here we have negative 18 times 14 gives me negative 252x. It's a big number. Minus 54 times 14, 756y equals 14. And then on the bottom, we know 14 times 18 is 252 again. Now 42 times 18 is 756y. 18 times 0 is 0. So whenever we look at this, we have things eliminate, both x's and y's. Sometimes that happens. Now we have to ask ourselves, what we are left with, can 0 ever be equal to 14? They are not equal to each other, so our answer here is no solution. Now, if you put these on Desmos, there is no point of intersection, which those lines are parallel. So you're going to have two parallel lines, and it's no solution. So we're always going to end up with 0 equals some random number. Now on this last example, again, I'm just going to switch my signs here. And that way my x's are opposite signs, my y's are opposite signs. 18 and 8 are smaller numbers, and I don't know what a number off the top of my head 18 and 8 both go into. So I'm just going to multiply 8 to the top and 18 to the bottom, and then these will end up being the same. All right, so let's see. I got 36 times 8, which gives me 288x. 18 times 18 is 324y. Oh, 18 times 8. Sorry, I made a mistake there. 144. And then 18 times 8 is negative 144 there. Then I got negative 16 times 18. Then I have 18 times 8 again. All right, whenever we did this, everything canceled. We are left with 0 equals 0, which is definitely a true statement. What happens here, if we were to graph this on Desmos, they would end up being the same line. You would not see two lines if you graph this on Desmos. So what it's saying is, like, you have one line, you graph it, the second line just goes right on top of it. So you have an infinite many of points that intersect because every point is a point of intersection on that line. So we say infinitely many. And if you want to abbreviate, I do allow that. So those are the notes for Monday. We're going to do a lot more practice with this week, and if you need me, don't hesitate to reach out, email me, Zoom, whatever we need. Just send me an email, and I will get back in contact with you. Have a good day.